Welcome to Mastering Solutions. In this question, I've redrawn the figure here of what we're given. We have this diamond, and they say that we need to figure out the path of the ray for the next two interactions with the surface of the diamond. And really what they're trying to get at here is, are we going to get total internal reflection? And so to figure out the critical angle for this, we'll use the equation theta sub c is equal to the inverse sine of n2 over n1. And so let's figure out what the critical angle is for the diamond, because then we can figure out all the angles. So we'll see if we get internal reflection or if we're going to get some refraction out of the diamond. So the two ends that we have is we have the diamond and it's surrounded by air. So we'll say the n1 is the diamond, because for the critical angle formula, the n1 has to be larger than n2. And so the n1 is going to be diamond. And from the book, we see in the table that it's 2.42 is the index of refraction. It's in air, of course, so n2 is going to be 1. And so the critical angle is equal to the inverse sine of 1 over 2.42. So inverse sine of 1 divided by 2.42. So that gives us 24.4. So 24.4 degrees. So we could just round that and say 24 degrees. So that is our critical angle. So what does the critical angle mean? If we remember, let's say our normal is here. If we have a critical angle, that is going to come in and we're going to get either no refraction, or it's going to totally internally reflect and we will get total internal reflection, like I said. So this angle here is our theta sub c, the critical angle. If we get one that is less than this, so we're coming in steeper, well, now it's not at a shallow enough angle and we will get some refraction out of the diamond. And so now as we analyze the path for the next two interactions of the diamond, if we get an angle that's less than 24 degrees, we will not get total internal reflection. And so that's basically what we're trying to see. As the light is coming in here, it's going to come straight down. We have it perpendicular to this line. So we can create a right triangle here. And so here's 90. And then this angle is going to be 90 and 41. So 180 minus 90 minus 41. So that angle is 49 degrees. So we have 49 degrees. And so that angle is not the angle that we're looking at, because remember, it's from the normal out to the ray. So this right here is our normal. And so this is the normal is always perpendicular to the surface. And so that's 90 degrees. So 90 degrees minus 49 will give us our other angle, 49. So we have 41 degrees, obviously the same as up here. So this is 41. So that is greater than our critical angle. So we will get total internal reflection. And so we'll try to get it as close as we can. And so it's not exact, but this is also going to be the 41 degrees, because the law of reflection says that the angle of incidence is equal to the angle of reflection. And so both of the critical angles are the same, as we said. And so both of these angles here will be the same. So now we need to figure out this one. And so here we have 41 and another 90. So same thing, this is also going to be 49 degrees. Now this one down here, this is not 90 degrees, so we don't know what these two angles are and we need to figure those out. And so we need to solve for this angle right here. We'll say that's phi, just so we have a different symbol. And so how do we figure out this angle? Well, if we look at the larger diamond, if we say this whole triangle here, right? So that triangle, if it's symmetric, then this one also is going to be 41 degrees. So now we have two angles and we can figure out this one. So that will be 180 degrees for the whole triangle. Minus 41 will give us phi. So 181 minus 2 times 41 gives us 98 degrees. So this down here is 98. And so now we can use that and this to solve for this one. So 180 degrees minus these two. So 180 degrees minus 98 minus 49. So that angle is going to be 33 degrees. So this angle here is 33. Now we have another, this is the interface where we get another interaction. So here's another normal that's perpendicular. And again, we have another 90. So now we can do 90 minus 33 to solve that angle. So this one, our new angle of incidence is going to be the 57 degrees. 57 degrees. And that will be the same right here. So that's also 57 degrees. And again, the angle of our incidence is going to be larger than the critical angle. So we will also get total internal reflection again. So we just solved for the next two interactions using a lot of geometry. And using the critical angle formula, we found that we will get total internal reflection because of such a large difference in the N of the diamond compared to the air. So this is the answer. Yes, we get total internal reflection for the next two interactions.